Okay, so here we go. So I think today's class is going to be absurdly short. I was going back through what I did last semester, and it was absurdly short last semester as well. I think what I need, the problem is I need you to do those two preliminary things before I get into the meat of the assignment, and I guess I need to combine them both to be due at the same time. But as it stands, your Stackus template is due Thursday night, so let me just spend 5 minutes or so talking about that. The idea is, to the extent that you've never created a template class before, this is your big chance. And when you're done, you should end up with this entire file here as a header file. So I'd make the first step to rename it from orig_stack.cpp to I just call it stack.h. And why is the entirety of the class in the header file for a template? Out of curiosity. That's the same for vector. If you cracked open vector, you'd see that its entire definition is in its header, or deck, or any of the other standard template library container classes. Anyone want to hazard a guess? So vector, book pointers. Why is it that all of the, not only this bit from lines 1 to 16, but all of this definition, whatever it looks like for vector, why it has to be in the header file as well? Any thought? Because we're not. Well, yeah, there's certainly, yeah, that's right. We aren't making, as part of the compilation process, whatever the CPP equivalent would be. However, that's certainly, there's a lot of stuff in the standard library, such as the source code to the input and output streams, and we aren't including those as well, yet those get linked in. So the linker could have been made to, if that was the issue, the linker could have been made to link those sources in, compiled sources in. It has to do with looking at, well, let's pick one of these. How about this one? So I believe that would compile as the template form of that function. Class is one of those things where they had just overloaded the name to mean type name. And you see that turns green, so they actually added that keyword to the language, and it's up to you whether you put class there or type name. I like putting type name because that's more accurately descriptive. My class can be any legal identifier. By tradition, it's all in uppercase. Frequently, when you look at tutorials, it's either T or type, I think, is probably what you see most frequently in tutorials. All right. So we did cover creating templates then?
Yeah, briefly.
Very briefly. All right.
I think it might have been a lab.
So it doesn't matter what you call it. I think my class is probably the least. How about my type? That's marginally more acceptable. Whatever identifier you choose, it doesn't really matter. Whatever you feel is appropriate. So the idea here is that lines 78 through 84, when you instantiate, let me change this now to stack, and I've got a stack of book pointers, that the code on 78 through 84, let me paste that down here, basically my type gets replaced by book pointer, right? This isn't the best example because that's the only place where I'm doing the replacement, but the reason why this has to be in the header file is because the compiler needs to know what it is it's compiling. For instance, it needs to know the size of the thing that it's returning in this example. All right? So these templates have to be expanded to show the type being used, as shown on line 93. Otherwise, it wouldn't know what to compile. Is it returning a pointer? Is it returning an entire book? Is it returning some other type? That information is needed by the compiler. So prior to the compiler attacking it, there has to be some sort of substitution process so that it has compilable code. So that's the rationale for all of the source being in the header. I'll just leave that down there for reference. So that gets to what is the process you want to use to convert this to a template. In assuming that you don't have complete mastery of templates yet, the assumption is you'll get online and spend 15 minutes with a tutorial to get enough under your belt to be able to do it. I would strongly counsel that your very first step be to convert this stack not to a template, but to convert this stack to manage a stack of floats. So just do some searching and replacing, manual searching and replacing, write a little test program to be pushing floats on this stack and popping floats off of this stack, get it all compiling and working. Once you've done that, you are 90% of the way there to converting it to a template. Now the reason I suggest that is because as it stands the way it's written, this thing currently works with integers. And trying to do a global search and replace of the word int with the word my type or whatever you've chosen isn't going to fly. And the reason that's not going to fly is because this integer right here is supposed to be an integer, right? The size is an integer regardless of whether it's a stack of floats or stack of books or whatever. This integer should be a generic type. So rather than you eyeballing it all to figure out what should remain an int and what needs to be changed to the generic my type, you get the thing working with floats, and then you can do a global search and replace, and anywhere you see the word float, you change it to this generic my type. And then after that, it's just a matter of adding the additional syntactic sugar required for templates, such as like this stuff right here. That makes sense? And so what you need to turn in by Thursday evening is basically a stack.h file that's been converted and works with templates. So get it working with floats, convert it to a template. You don't have to turn in test code, but write a little bit of test code to make sure that you can pound include your stack.h and create a stack of whatever objects you like. Any questions on that? Any questions about anything else? All right, as I said, it was going to be short, so I should have rolled the two together, as I said. But go ahead and have at it, and then when we meet on Friday, you should already have well in hand the syntactic art of putting together exceptions as well as understanding templates. And then Friday, I will dedicate towards saying how you attack this project for implementing exception handling.
I was going to say, even reading through the documentation for exception handling is still the
Do you have specific questions you want to ask?
Well, I'm just curious, like, how to apply it to what, to accomplish a goal that we're trying to get.
Right. So I'll be the first to say that you should not yet know how it's going to apply to this stack, because I haven't had that talk yet. We can look at some examples of how you'd use it otherwise. So if I look at, let's see, how about a map? Or maybe vector. Let me try vector first. All right. So this is a member function of vector. It returns a reference to the element at position n in the vector. Automatically checks whether n is within the bounds. Throws an out of range exception if it's not. Okay. Let's create a vector of floats. Yes.
It gets pushed back.
Get pushy with me, huh? There is. Print that out a couple times. Should be 3, should be 5. Okay. Now let's say all right. Now let's try at 30. Terminated with uncaught exception of type std out of range. So now what we can do is we can put a try block around this. We can catch anything at all that it might throw.
So catch really just whatever exception is thrown and catch it. Or we're telling you what to catch.
Catch with 3 dots means catch absolutely anything. It's kind of the default case. It'd be, what I've done here is the equivalent of this. If I say switch C default do something, right? It's just going to get everything. So that's what this catch is going to get. Okay, so there's the catch. It completes all the code with the catch, and then it continues executing on line 20. If there was no error, so if I put this at 1 again, then it does not go into the catch block. It just basically goes from line 14. Line 14 is successful, then it goes down to line 20. Let me zoom in on that. So, whoops, that's what I wanted. Let me zoom in on that, so it's a bit. So it says it throws, we can say catch courtesy compile. We shouldn't see any change in behavior. I'm just adding code. I can catch integers. If I read this, it's going to throw an out of range exception. Let me click on that. So I have to include the standard except. And then I'll just actually just grab this note. It's being passed in by constant reference. So this takes on an additional connotation beyond good practice. The good practice is, why do we want to send in a copy of the out of range exception? It's inefficient, constructors are called, you know, that whole thing. Here, the additional meaning that it takes on is that you don't want to be calling additional functions. The more code you're invoking, the more likely that's going to throw an exception, and then the whole thing goes to hell. There's no chance of, if there's an exception thrown, there's no and it's caught by line 17, there's no chance of that exception running functions that then generate yet another exception. Now that isn't so much a threat of these, because they're designed not to do that, but you could potentially have you can throw anything in here, right? You could throw a book as an exception. Yes?
So for line 17, if you were to throw some other error, some other exception, line 17 won't catch that unless it's an out of range exception.
That's correct. So let's.
And then line 25 would catch that other error.
Right. So let's go ahead and let's try this. Okay, I need to set at 30 or 20 in this case. So vector is the what, and what you can do is drill down to these generic exceptions and find out. Let's go down even further. Let's go to the base class.
And so when something's being thrown, it's just simply if a specific condition is met, it's just setting the exception value or whatever.
All right, so what? So somewhere inside of the source code for vector, you have the line throw and this is running a constructor, right? Really, if I wanted to, if there, let me just pseudocode it, a problem, then it's going to create right, it's doing something like that. That, again, lines 16 through 20 would be inside of the @member function of vector. Now, I'm sure they've optimized it, so this is the, get rid of that. This is the easier to understand version. What they're probably doing is doing throw. They're actually creating it and throwing it at the same time. Yeah.
So the string which is passed into the exception class constructor, it's printed by the what? But it's returned by the what?
Yeah, so you've got this member function right here, which is get string identifying exception, right? And you can read about that. And that is, note, it's in the public member function of the exception class, which is kind of the base class of that standard exception hierarchy, which you're under no obligation to use. Again, the main reason for supplying this is that it provides a mechanism for all of the things in the standard library to throw. Your own application, you may very well create your own hierarchy of exceptions you want to throw, or maybe you don't need to be that sophisticated and all you need to do is throw a string, right? You can throw whatever you want. So looking at all of this, let me go ahead and make this a valid statement once again, where, let me see, let me take, I'll delete that. Let me take 16 through 20 and delete that. I'll put it down here, what it looks like in vectors @member function. So now what I can do is anywhere inside this try block I can say throw 32. It should skip this one. It's just like a switch statement. It'll skip that one, but then it's going to catch this one on line 22. And then the catch-all, oh, what's something I can throw? I can throw some string, and then it should say I made a boo-boo, since it is neither that nor that. And I did make a boo-boo.
When you were relating it to the switch cases, you were saying that throw is like the switch and catch is like the case.
Catch is like if you have a bunch of catches chained like that, the way to interpret it would be similar to how you would interpret it in the cases of a switch statement. Your try block just contains code that is presumably unstable, and so you put a block around it, right? So a generic example would be if you're writing code that's going to be running the heads-up display in a fighter jet, you don't want the thing bailing out with an exception. So anywhere where it's possible for there to be an exception, you'd put a try block around it, with the idea being that you try and maybe correct the problem. Or do something, change some flags or something, and let it try again. Yeah.
I've always kind of wondered about, like, because, like, more dynamic languages, they kind of just, like, keep going. Like, even if there's, like, an error or something,
In dynamic languages?
Whole thing, yeah.
Well, it depends. I mean, I've certainly written my share of Python programs that burn a horrible death. Um, so,
I guess the one that I'm referring to is just like JavaScript. That's the one I've used the most.
I don't know. It's been years and years since I've used JavaScript, so I can't speak intelligently about it. But I would assume if you try to divide by, go into JavaScript and try and divide by 0, does the script continue after that? Now the web page is still up, and there's probably facilities for JavaScript to run a bunch of threads concurrently. So maybe this part of form validation is still working while your error over on this field is stopped, right? So that's right. Yeah, that might be the deal. Yeah.
So you were saying, like, if you were to throw an exception, try to fix that exception in the program, maybe some things don't blow up or whatever. I remember quite a few years ago, probably 20 years ago, there was a jet fighter that was doing some testing out above Utah, and they had a number in their guidance system that was a negative when it was supposed to be a positive. And so when they turned on their autopilot, it went pushed straight into the ground.
Okay. Well, that's living the life of a software tester.
So in such like a situation, you could say if you try this, if the catch if the number's negative or something.
Yeah, and right, exceptions aren't needed in all circumstances. You could have just some, like take user input. You don't have to throughout your application be ready to handle a negative number. You can just simply refuse to go on until the user enters a positive number, right? So no exception handling is needed in that case. So an example where you see these exception handlings is just this kind of case where, and we're gonna see how this affects us in the stat class, but for the vector, it doesn't know what to do with that invalid data, so it's going to throw the exception and saying, hey, you're the one using vector, you figure it out. Yeah.
Example of where exception handling would be useful. Sometimes there's like using a desktop app, and it crashed, and there's like a window which pops up. This program requested the runtime to terminate it in an unexpected way. So that's because of exception. That's because of an unhandled exception.
Well, presumably, yeah, the application crashes and burns, so the operating system has to clean up after it. Yeah.
Say you had like a pretty big extensive thing. Would it be like really naive to just like put exceptions on like all of your functions to like return safe values or something so that it can like keep going?
Yeah, I think it'd be naive just simply because I would question whether it would be valid to keep going. Errors just cascade and the thing won't die, and it mutates into this Frankenstein monster of invalid behavior. And then you end up with Skynet. So that's the purpose of the stack project, is for you to get one view of what it means and why you would want to put in exception handling. I'd say the stack ends up being a really nice use case for having exception handling. So does that help? That give you kind of a better idea of generically what it is? That's what I was looking for, that you kind of understand the syntax of how to do it, not necessarily the semantics of where you should and where you shouldn't. But if you're asked to regurgitate this on like a 211 exam or something like that, right? Go try, throw, catch, does this, that, and the other thing. Yeah.
So I think would be more appropriate than simply keep going on is having an exception handling and maybe like saving some work from the random access memory to the hard disk, or maybe closing some files, and then next.
Well, that would be, yeah, so part of the catch is cleaning up the mess, definitely. If you have open file descriptors or something that you want to close before going on. Close a database connection that otherwise won't close on its own. I mean, there are any number of things. But again, it isn't a panacea. Why not just simply an if statement? If the thing was unsuccessful, then close down the connections, right? So there are definitely specific use cases for it. One to consider a difference from one area where exceptions are convenient is if you have a function calling another function, and that can happen quite nicely if say you've got these member function calls, like recall the constructor for report. Not only does it run reports constructor, but it runs dates constructor and times constructor. And you can imagine if date was complex enough, it might have its own classes, and it would run constructors down there. So you can very easily in applications programming, without realizing it, get really deep down. And throwing an exception allows you to unwind that really quickly and get back up. Imagine trying to architect the same thing with a bunch of if things failed, then return out of the function, right? It becomes a lot more complex to try and engineer that and down all the levels that you might be going. So it's a nice way to unwind quickly back up to a certain point. Yeah.
Why would you maybe exceptions versus asserts? Are asserts more to catch like programming errors?
An assert would be something I would never put in production code. I'd only use an assert as a debugging tool. Because an assert will end the program, unless that's acceptable behavior. And, you know, by and large in this academic setting, I know that Tyson's a big fan of asserts, and that's fine. You know, you're just working on the school project, and it's a nice way to make sure that it's handling all possible inputs. But yeah, you wouldn't, I don't think you'd be shipping out some sort of mission critical application to the customer that's going to crap out on you with an assert.
Assert use like more of a testing tool.
Yeah.
There's a debate in the security community that you should leave asserts in, because then when people get into your code and they're trying to manipulate it, the assert will stop their stack overflows or buffer.
Yeah, yeah. So take what I say with a grain of salt. There's certainly arguments you can make for it. The counter argument is, well, if you have an assert there, you're anticipating something could go wrong there, and why don't you engineer something less harsh than having the whole thing in, unless that's acceptable behavior, and in some cases it may be. It's not acceptable behavior if it crashes and gives your customer a root prompt, right? Anything else? All right. Oh yeah, go ahead.
Yeah, can we talk more about the assignment real quick?
The
End up
for
repeating yourself.
no, that's fine. That's fine. For the making the stack template.
Well, so the whole thing at the very end, we're rewriting the entire class, right? Because it's bad at the moment. But for Thursday, we're just converting the normal class.
Right.
into
So okay. So let me provide a little bit more detail. When we finish when you've turned in the finished project, it is not a stack I would choose to use in production. I think it's a naive design, and it's got problems. For instance, here, if you want to here's a classic example right here. If you, if you want to pop an element, it returns that element to you. Now that's intuitive and natural, right? Pop a stack, grab it, and do whatever. If you look at the standard template library implementation of stack, the return type of pop is void. It doesn't give you anything back. And the reason it doesn't is there are potentially bad side effects of returning this object. For one, it's returning by value. So you don't get the original object back, you get a copy of it back. So think of if this was a stack of books, right? So if you were to look at the STL implementation of stack, there's an accessor and then pop, which is void. And the accessor will give you a reference back. So it lets you work with the actual objects in the stack rather than copies of them. So you would access them and do whatever, and when you're done with it, you just pop it. So let me say up front, when we have this thing, quote, fixed, it's not something I would consider production-worthy code. As far as it being broken and rewritten, it isn't wholesale rewriting of the entire class. It is reorganizing code inside of these member functions. So for instance, this push function, we will see that the order of things can be rearranged to make it better. Like take line 63, right? Strictly speaking, you can put line 63 anywhere within this function prior to a return statement. So for instance, if I move this to the bottom, I could always say current size +1, and I'd get the same behavior. So although I haven't revealed whether that's a good idea or not, I'm just saying that's the kind of thing you end up doing, is rearranging this code so that it behaves properly when you implement exception handling in it.
But for Thursday, we're just changing it.
Yeah, for Thursday, I'd go ahead. I've said before that if there's any exception handling in here, it's bad. Feel free, if you leave it in there, I don't care, but I would recommend like taking lines 68 and 69 and just deleting them. Anything that's exception handling in here, and the only thing that is exception handling, I shouldn't say handling, it does throw exceptions in some places, and it's always preceded by an if statement. I just go through and get rid of that stuff. And then, as you said, beyond that, just add the template sugar to it, and you're done. Yeah.
We have to implement our own exception handling for things that we may consider it may cause an exception. So we delete the old exceptions, put in our own.
The goal of the project will be to implement exception handling in this class. I would not do it between now and Friday. You're invariably going to anticipate incorrectly my expectations for the project. Anything else? All right, so I guess not so short after all. We'll go ahead and end it a few minutes early, and then on Friday, I'll stop being obtuse and I'll say, okay, this is the problem with it that we have to fix with exceptions. Yes?
Just one more thing. You have try block, and immediately after each other, catch, immediately after another catch. Can you have code between the try and catch, between the different catches? Can they be loosely organized?
No, the catches should be chained together.
Should be chained together, but the try can be anywhere, separated from the catches. Like
the catches immediately follow the try. Right? It's try, curly braces, catch, parentheses, curly braces, catch, parentheses, curly braces. You've got to have that kind of syntax formation.
like if else. Like if else.
Yeah. So with an if else, assuming you're using curly braces on your if clause, that can have an arbitrarily large amount of cruft between the curly braces, but at the end of that close curly for the if clause, then you immediately have the keyword else. All right, we will see you on Friday.